I'm going to just very briefly explain here a concept called pooled testing. The problem is, as the Covid-19 pandemic spreads, we run out of test kits and reagent. And we know that testing is key to stopping the spread. The fact that somebody doesn't show symptoms doesn't mean they're not contagious. So what is a better testing strategy? What I'm going to describe here is just one approach to something called pooled testing. You combine multiple samples into a pool. If many of those you test are negative, you can save a lot of tests. And this is an old idea, but it's important to test old ideas in a new situation. It has been shown to be effective for COVID-19. There are many variants on pool testing. What I'm going to illustrate here is one called an array. The first thing is you pool the tests in a horizontal direction. So here I've got 100 samples, and each row I mix all the samples. So there are 10 mixed samples in a row, and then each row is treated as one sample for test purposes. So you end up doing 10 tests, and what we see over here is 3 of them have come up positive, but we don't know which individuals they were. There could be anyone in those rows. So the next step is you pool in the vertical direction. So you take 10 samples, this time one from each row, you pull them down a column, and you do 10 more tests. And the consequence of those 10 more tests is we find 3 positives again. So the next trick is to identify the intersections between the positive and the negative tests. So we've got 9 individuals who may or may not have been the ones who tested positive. And remember, we've done 20 tests so far, and we've narrowed our 100 possible positives down to 9. So if we now pull out those individual 9 cases that were at the intersections between the horizontal and vertical tests and retest them, we now find 3 individuals that were actually positive, and that has taken us a total of 29 tests. Remember, we found 3 positives out of 100 individuals. If you look at where those 3 were in the original layout, we can see how we managed to narrow it down to only 3 individuals with 29 tests. And what that means is we've saved 71% compared with testing all 100 individually. So, in summary, if we have 3% who tested positive, we can save over 70% of the test cost by pooling, and that 3% is about the rate of positive testing in South Africa. It not only saves costs, but also time. So this is just one approach, and this is an active area of research. You can dilute the samples more than this, but the downside of diluting the samples more is you could miss some positive cases, but on the other hand, on the plus side, you can test a lot more. And so if you're running out of reagent or test kits, this really is something you ought to be